Okay, we're recording. This is the Boston AWS meetup, aka the Boston user group, and we're very pleased to have Nick talking with us about securing your workloads at scale. So take it away.
Thank you. Hopefully you can all hear me okay, he says. Is that all good? Yep, fantastic. Okay. So yeah, I'm here today to talk about securing your AWS workloads at scale. And what I mean by at scale is when you're working for an organization that's got more than an app or two running in a couple of AWS accounts, the challenge starts becoming keeping track of it all as much as anything else. And so a lot of what I'm talking about here are things that people struggle at as they scale their AWS use. But there's still a lot of good stuff in here, I think, for people who are still running quite small estates. Hopefully everyone will be able to take something away. There's three sort of key areas I think I'm going to aim to cover off here. The first of which is, what does your cloud security landscape actually look like in practice? I think a lot of people have some interesting conceptions or misconceptions around that. So we'll spend a bit of time talking through that. How do attackers actually target workloads in AWS? It varies quite a lot. There's a few different bits and pieces to unpack there. But again, not always the obvious ways. And if you're going to invest some time and effort into some security controls and presumably some budget from somewhere too, where to prioritize that, where to start, and what to put at the top of the list. As to who I am and why I'm here talking, I would say I'm talking from sunny Copenhagen, but it wasn't that sunny today, and it's now very not sunny because it's pushing midnight locally. So I'm a senior security consultant and the cloud security leader at F-Secure Consulting, and an AWS community builder, which is how Brian and I started talking. I spend a lot of my time talking about various things, mostly detecting attacks against AWS, but when I'm not doing that, it's we're trying to break in myself for various clients who've paid us to take a look at their security. And I'm also the lead developer on Leonidas, which is an attack simulation tool for AWS that I'll get onto in a bit. So first place to start, your cloud security landscape. What matters and what should you be thinking about, what aspects of it when you're looking at planning out your security work, building all your controls and things. Most people, when you say cloud security, have an image in their head that looks something a little bit like this. You've got an AWS organization, perhaps with some accounts in it, maybe a dev environment, a staging, a production, maybe that cloned for a bunch of different workloads. If you're lucky, you might have some continuous integration and deployment systems deploying all of that. Sometimes people think about that for security, sometimes not. But that's usually the picture that is often painted, especially if you talk to AWS, they'll tell you, that's the stuff you worry about. In practice, I don't think I've ever worked with a single sort of medium to large enterprise that's been only single cloud. There's always, we're all in AWS, or we do Azure here, and then there'll be an engineer stick his hand up at the back and say, well, actually, hang on, there's this one other thing in the corner that you've forgotten about. And often there's another engineer who says, well, that was Azure, and then this one's Google Cloud as well, and the next thing you know, you're in all three providers. But even if you're not, your source code's probably in GitHub. You're probably using container images that you've pulled down from Docker Hub. You've probably got Slack, maybe Office 365, G Suite, something like that. And actually, your security posture for your cloud environment relies on all these supporting systems that all talk to each other. And if an attacker can, for instance, get into your GitHub and they can start replacing some of your source code or your Terraform cloud formation for building your cloud infrastructure, then that's about as good as getting access to your cloud infrastructure itself, really. So I guess what I'm saying is that there's a bigger box to draw around all this than I think a lot of people initially start thinking about. And an attacker will be thinking about all of that because often the bit that's running in AWS is actually quite well hardened, especially if it's relatively new. And so they're likely to start somewhere else that looks a little bit of a softer target. So I'm just going to pause for a second there. I'll pause at various points through the presentation. Any questions on that so far? Does that all make sense as a starting point?
Yeah, the one comment I'll say as a big Lambda fan is I'm very, very happy not to see Lambda on this slide of vulnerabilities.
yet.
Sorry, you're breaking up.
All right, fantastic. So then, yeah, now that we're considering the whole picture rather than just smaller individual pieces, let's talk about what an attacker is actually likely to try to do, how they might target your cloud estate, and perhaps dispel a few myths along the way. At various points through this presentation, I'm probably going to deviate from Amazon's collective PR wisdom on how to do all of these things. Part of that's because of things I've seen in the wild. Part of it is differences of opinion between me and the people writing all the guides at AWS. But I will do my best to explain why that's the case when that does come across. And this slide is probably going to be one of the first places that happens. So attackers always look for path of least resistance. An attacker will be as lazy as they possibly can be in order to achieve whatever goal that they've got. So a lot of attacks are opportunistic. It might just be they find your credentials as opposed to someone else's, and so therefore they take advantage of that. Unless you're an organization that has a lot of value for either intellectual property reasons or national security reasons or things like this, the majority of attacks are likely to be opportunistic. The other key thing is that getting the basics of security right tends to stop a lot of the really advanced stuff too. And my favorite example there is always the SolarWinds security breach that happened at the end of last year. And the really interesting bit of that for me was that what got them caught, someone tried to register a new two-factor authentication device for an employee. And the employee said, oh, hang on, no, I didn't try and do that. And their security team said, oh, hang on, well, someone's tried to register a new two-factor auth device for an employee who didn't want it. That doesn't look right. Let's go investigate. And just because someone had said, oh, hang on, no, this wasn't me, and someone took the time to investigate that, it unraveled a multi-year long Russian nation state breach, one of the most advanced we've seen in quite a while. So getting the basics right can help stop a lot of the advanced stuff too. So that really is often the place to start, getting the basics right. And we'll get into some of those later on. Most people get breached because they've gotten the basics wrong. That's the sort of the extension of that. Forgotten AWS accounts is a big one, or legacy accounts that are managed under the centralized management structures. That was what got Capital One breached. They had a legacy account that they hadn't brought in under all their usual compliance mechanisms, and so some stuff got lost and forgotten about. S3 buckets with public access. If you've not turned the block public access switch on in your AWS accounts, probably do that first thing tomorrow morning, because that is, I don't know how many AWS breaches I've seen that started there. And these days, it's a pretty easy fix. Amazon have put a lot of effort into making that harder to get wrong than it used to be. Leak credentials. So part of that is people accidentally checking their access keys into GitHub. Part of it is shared passwords between systems, and one thing gets breached and your password ends up on the internet and attackers try and use it elsewhere. I think the last copy of the Verizon data breach report I saw, they say something like 70% of cloud breaches they investigate are credential theft of some sort. So not checking your access keys into GitHub and revoking them when you do is definitely a key thing there. And the last one really is, people giving the administrator access policy or an IAM policy that says *:* in the permissions field is a really good way to make sure that something goes wrong if an attacker gets a foothold. So everyone always talks about principle of least privilege. In practice, it's actually really hard to get that right in most environments, but just spending a bit of time to make sure that you're not giving admin access or equivalent to loads and loads of stuff. Just scoping these policies down a bit to be a bit more specific can actually go quite a long way, even if you're not going to go the whole hog and finely tune everything in your IAM configurations. And lastly, things that won't get you breached, or almost certainly won't. Obviously, now that I say this, someone's going to get breached by this tomorrow and I'm going to look like an idiot, but you're probably not going to get breached because your encryption at rest was misconfigured. Auditors love hating on people for not having that box ticked, but the threat model that leads to that being the problem involves either people physically breaking into an AWS data center and somehow picking out your hard drive from the huge collection, or serious weaknesses in AWS products themselves, at which point the encryption at rest is the least of your concerns, frankly. So what we usually recommend is tick all the default encryption boxes because then your auditors won't get upset with you, but I don't generally invest much more time in KMS than that. Equally, Amazon love pushing awesome new security technology, and I always love reading these press releases because they've got some incredibly smart people doing some very, very clever things. But for instance, not using Nitro Enclave to store your cryptographic key material is probably not going to be the thing that gets you breached. When that first came out, for instance, I had a lot of people, or I was hearing a lot of people saying, oh, this is great, we can now segregate all these things out in our application. And probably about 70 or 80% of the people were saying that while not having properly locked down all their S3 buckets and with stupid IAM permissions scattered across their estate. So you have to be careful to prioritize what actually matters. Nitro Enclave's probably not it. You're not likely to get breached by an AWS 0 day. I say that fingers crossed because Azure's had a really, really bad month bad time over the last month or so, with sort of 4 or 5 major vulnerabilities that got discovered that were a really bad time. AWS hasn't seen that kind of issue yet. Probably happen at some point, but in the grand scheme of things, most people are getting breached because of basic mistakes made by the customer, not because of something AWS has done. And equally, I often see people being really concerned about what an AWS employee might be able to do with your data and all of these kinds of things. And the level of protections and controls around who has access to what data and the approval workflows for all of these things at AWS are known to be very, very rigorous and rigid, and they have to be in order for AWS to meet a whole load of their compliance regimes that they subscribe to. I think they're subscribed to about 27 or 28 at this point, and none of those audits would have been passed if that wasn't fairly well built. So disgruntled engineer at AWS also not likely to be the cause of your problems. Any questions on any of that before I keep going?
Yeah, hey Nick, what the difference between using AWS managed keys or KMS is that? Where does that fall? Because I never bother with KMS.
So you should always tick the please encrypt my stuff at rest box, which uses the default Amazon keys. Right. There is a fantastic blog post that I will dig out a link to after the talk called "Cloud Encryption is Worthless. Click here to see why." That was written by Chris Farris, who's I think he's at Time Warner. He's one of their cloud security people. And essentially, the level of effort you have to put in to get real security value out of having CMKs everywhere is really quite substantial, because you've got to be scoping down the key policies, managing your key grants, all of these other things in order to get more value out of it than just, oh, well, now this is a key that I can choose to delete if I want to, which doesn't really help. So it's very, very rare that I spend time working with clients turning on CMKs and managing all of that, because most of them have far bigger problems to attend to before they start thinking about that.
Awesome. So you just relieved a whole bunch of possible guilt that I've been feeling over years. So good.
Oh, well, happy to do that.
Key management is probably one of the harder things to do in securing things. And it's like saying, okay, I'm going to put a lock on somebody digging a tunnel under the foundation of my house, right? When you've left the front door unlocked. So focus on locking the front door first before you worry about somebody tunneling under your foundation.
Exactly. And this is why I always have a good chuckle. My AWS security specialty is about to expire in December. If you go through the training material for that, it's about 25% KMS, which I'll sit through so I can go past the exam, but it's probably not going to get used till I do the exam again the next time.
I do have one question about the least privilege, because I'm at a place where there's more stars than there should be. And but unfortunately, we've also had enough turnover over the years that, I say, who uses this resource? And it's like, I don't know. I suppose we could find out if we buttoned it up and then we'd see who screamed, which is, not ideal. But I haven't played with it, but somewhat recently there was some version of Identity Analyzer that would say, here's a policy that's the least privilege policy that would have granted the uses I saw during the time you had me look.
Interesting. So I wasn't aware Access Analyzer had brought that in, but it's pretty cool if they have. There's a tool called Cloud Tracker kicking around on GitHub that did that as a poor man's thing with CloudTrail logs, back before AWS got around to building it. But if it's in Access Analyzer, then that sounds like a pretty good way to go.
Right. The trick, of course, is that it will only grant for the things that it saw. And so what I've been afraid of is, okay, let's suppose the system starts to go sideways. It makes some calls, some legitimate calls that it didn't make before, and we securitize ourselves to death in the middle of an already squirrely situation. So I'm not quite sure what to do about that. But anyway.
Yeah. So Brian, I think the answer for those things is those analyzers, which I think is it's a new feature, which is great, but it requires a fairly steady flow that you can pretty be sure that you've actually sampled the environment. And if not, you still, I think, need to take it as advice and still need to understand the system. Like it saves you some of the typing and work. But I think I wouldn't take the results and say, oh, it said this is all it's being used, I'll just use that. So, I think I wouldn't use it on a system where you don't have good coverage through daily activity.
So you're suggesting I should understand the system before I modify it? That's just crazy talk.
I know, I'm out there.
All right.
The other thing I would add to that, Brian, is that least privilege is not a static thing. And to do least privilege well, you have to have it's a process. You have to have a process behind maintaining the least privilege, and you have to build habit into your workflow where you assume a role to do a specific task, and then you drop the role, and then you pick up the next role for your next task. And a lot of people are not used to working in that way, where you log in for we're talking minutes, right? And then you drop the role. People are used to like provisioning an account with, okay, here's everything that I could ever possibly use in a week, kind of a thing. And narrowing it down to where you log in and out of roles all day long, that's a very different workflow. People are not used to working that way.
Right. And actually, if I can say, currently, we have a horrible role switching thing. It's using the Chrome extended role switcher plugin. And I have not yet tracked down who wrote it so that I can have a conversation with them. But we're switching to SSO. And oh my God, does Amazon SSO make this so much easier? So anyway, I could talk all about that, but we could even let the presenter speak again.
So I could talk all day about all of that stuff. IAM and least privilege and how to manage your role assumptions and things is a multi-day training course, I think, by and of itself, really. But moving into how attackers typically break in, the big four really are public S3 buckets, and it is usually S3 buckets. Azure and GCP don't have the same problem. It's pretty much always the AWS ones. Web application vulnerabilities. This was the main reason behind the instance metadata version 2 release for EC2. What was it? A year, 18 months back. Was to reduce the impact of some of the web application vulnerabilities that people have been hit by. Exposed credentials, checking them into GitHub is the classic, but there's a few others. And as an aside, we'll get onto that in a second. The last box there is targeted attacks, and what I mean by that is people getting phished the same way that attackers have been phishing people for however many decades now. That is still relevant in the cloud. People still fall for it. The important thing is that people will always fall for it. And we shouldn't make people feel bad for falling for it. I have a personal hatred for a lot of these phishing training things that spam people and then, call them out for failing it. Because the way to build resilience in a business is to make sure that things like that can happen and it not be the end of the world, not to make sure that your people are publicly flogged for failing a phishing test. But that will still happen an awful lot. That's not going away anytime soon. And it's still one of an attacker's favorite paths into the cloud, to phish and then gain some level of access from there and move around. So on the public storage front, it's not good. It's really not. That Grey Hat Warfare website in the middle there is a consistently updated list of currently open AWS buckets, Azure blobs, etc. That there's some kind of crawler bot that runs in the background and constantly updates it. We see tons and tons of breaches tying back to this. But I think everyone's probably at least heard of the S3 one. The other ones that we're starting to see more of are public open search instances, as I guess it's now called, used to be Elasticsearch Service, and also public DynamoDB databases. There's actually a list of about 14 or 15 data storage mechanisms you can make public, EBS snapshots, RDS snapshots, all of these kinds of things. I can't remember all of them off the top of my head, but people making things public where they shouldn't be is still one of the biggest problems in cloud security, and is likely to continue to be for a while. The particularly interesting one from a web application vulnerability perspective is the instance metadata service. Essentially, if we can, let's get the whole diagram up, he says. So essentially, you make a request to the application, you trick the application into passing your request on to the instance metadata service. And the instance metadata service has a lot of things in it, but it's got the credentials associated with the EC2 instance role. And so if you can get that returned to you, there's a class of web app vulnerability called server-side request forgery that is what's usually used for this. As an attacker, you can steal the temporary credentials, they're not valid for very long, and then use that to go do whatever you can do with those credentials, right? And this is one of those cases where what I said earlier about not having *:* everywhere is important, because whatever credentials might come back from that, the attacker is limited to what they can do based on the IAM policies you've assigned, right? So if your IAM policy says this role allows me to talk to this one S3 bucket and that's it, might not be game over just yet. If that role says, administrator access, you're in for a very bad day indeed. So the instance metadata service version 2 makes this a lot harder, because the way that this particular class of vulnerabilities work, the way they've made instance metadata service version 2 work with the extra requests you have to make, basically breaks this entire thing without serious significant other problems. So also turn on instance metadata service version 2 on your virtual machines. I think there's now a tick box to do it on all new instances account wide. So worth doing that unless you've got legacy apps that rely on version 1. No, that's not relevant. You'll have to excuse a few of the Azure diagrams. I've borrowed them from a previous talk. When we're talking about targeted attacks, this is where some of this gets slightly interesting, and I'm going to pick on 3 particular pieces here that all fit together. One of which is the identity management angle, one of which is moving between environments, and what I mean by that is either on-premises into the cloud or vice versa, or between different cloud estates. And lastly, all the source code management, CI/CD things that I mentioned at the start. And so by identity management, it's either the access keys in source code, or it's attackers stealing people's credentials via phishing or whatever else. Super common. And two-factor authentication really is your best and biggest defense here. Either attached to your single sign-on provider or enforced in your IAM policies for the roles that people are assuming. But two-factor authentication makes an attacker's life an awful lot harder. And it's really made our red teamers cry as they've started seeing people roll this out more commonly, because it makes their job a hell of a lot harder when they're trying to break into to banks or whatever they've been paid to do. What tends to happen, though, is often once we've stolen some credentials, we might not necessarily be able to jump straight into the cloud. And so, for instance, in the case of SolarWinds, they breached the Windows on-premises old school legacy stuff, compromised that to the degree where they had admin access to the vast majority of things, and then used the Active Directory single sign-on to legitimately sign themselves into the cloud as cloud administrators. So it was a case where I think the cloud estate was actually pretty well hardened and fairly secure, but it fell prey to a much weaker legacy on-premises network, and that being the weak link in the chain, so to speak. Does all of that make sense so far? I'm going to pause for questions and things. Okay, cool. So again, more Azure diagrams, apologies. But if you imagine this in the AWS world, replace Azure DevOps with code commit and code build, or GitHub and GitHub Actions, or whatever else is your choice. The core message here really is that if you're doing continuous integration and deployment, or you are sort of semi-automatically, mostly automatically deploying based on what's in your source code repositories, you are going to have a bad day indeed if an attacker manages to alter significant amounts of things in those repos or gets access to those continuous deployment pipelines. And the pipelines in particular get very interesting for an attacker because they usually hold some sort of credentials, or they have roles assigned to them or something that gives them complete administrative or near complete administrative access to your cloud workloads. It's how deployment systems work, right? So if as an attacker I can get in there and start stealing those credentials, that's going to put me in a very, very powerful position. So it's quite common when we start talking to companies about their security, they'll be looking to buy a test of whatever their production setup is, and they'll often exclude things like the single sign-on platforms and the pipelines, the code repositories, these kinds of things, for cost reasons, because if they're being regulated and they've got to show they're doing security or anything like that, they often don't have to tick those boxes in order to meet their minimum regulatory requirements. But you do end up missing some really quite key security problems, I think, if you leave those out. And when I go in and I'm doing my offensive security testing and I'm trying to compromise the environment, the pipelines especially are always my first and favorite target, especially if you're running Jenkins. Sorry if anyone's a fan of Jenkins in the crowd, but it's not usually a good day.
Nick, I've got a question for you, because exactly this has come up recently in that we're starting to use a control tower and guardrails. But a bunch of the guardrails only seem to make sense for people. So like the guardrail that says you can't do such and such a thing without MFA, but Jenkins is not going to MFA.
No, and this becomes one of the real key challenges, right? So there's no sensible way of doing any kind of two-factor or secondary authentication really on any of those systems. So we've been thinking quite long and hard about this for a while, and the approaches that we've seen work, one is basically segregating all of your pipelines and code repositories out. So we've seen quite a few organizations managing individual code pipeline deployments for each thing they're working on. So if an attacker breaches one, you've only compromised that workload and not all of them. That sort of single Jenkins instance that powers an entire organization, is a model that a lot of organizations started with for CI/CD, and it is really, really bad from a security perspective. So we're seeing people segregate them out, code pipeline and things make it easier because you can just deploy more of them. Or equally, if you're running on GitHub and you're using GitHub Actions, having fairly fine-grained controls over who has permission to do what with what repositories and actions is also quite effective there. The main problem with Jenkins is basically it's just so legacy at this point, and it comes with so many plugins that people have piled up on it and all of these kinds of things, that it tends to be very, very difficult to build a secure platform on top of these days.
Okay. The one other thing, and other people jump in because y'all know I talk a lot, but the other thing that has sort of leapt to mind is, as I'm doing Alexa skills and I'm using the Alexa presentation language, the way it's set up, all of they recommend and say that it'll only work if you put your audio files and your video files in S3 and make them public. So here's Amazon saying to make public buckets. So
Okay.
So somebody should talk to them.
So I will also say that there are a few semi-legitimate use cases for it, in that if you can't be bothered with CloudFront and things like that, hosting a public website in S3 is something that you can do. And if it's supposed to be public, then, well, fine, it's public. I'm not going to get into a debate about that one. It's, if that's what you want to do. But my overarching feeling is generally most things that require public S3 buckets could probably be done in a way that didn't require public S3 buckets, except for apparently a few things that Amazon are forcing on us if you're working with Alexa. That's a new one. I wasn't aware of that. Okay. Any more, or I'll jump into some of the key controls. Okay, awesome. So key security controls. I mentioned identity quite a lot there, authentication and these kinds of things. Multi-factor authentication everywhere, both in AWS and all of the other things that you use. This is by far the biggest win you can make as an organization, effective MFA everywhere, in terms of preventing a lot of the common sources of breaches, right? If your external perimeter is reasonably well patched, MFA is the next big thing to really, really make an attacker's life much harder. Generally, everyone likes YubiKeys, thinks they're a great idea. They tend to be a pain to manage at scale, so a lot of organizations don't bother. The apps tend to be pretty good. Google Authenticator, take your pick. The only slight problem with them is a crafty attacker might try and phish people for their two-factor authentication codes as well. But still significantly better than nothing. SMS is better than nothing, but a last resort generally, I would say. Amazon support a few different types of hardware tokens, and the applications, I don't think they do SMS. Next up. Oh.
I'm sorry, I'm just going to throw something in there because I encountered it recently on a client. They've got something, it's a third-party managed, hosted in AWS, and it allows, well, we're using Okta for SSO, but it also allows direct login. And this particular app doesn't really give you a way to prevent nicely the direct login. And so you have to sort of be careful that there's some apps, and I've seen it more than once, where you can enable your multi-factor, but there's still the direct link, and that doesn't help. So just be aware of that. And
we do still see it with AWS, where you got nice two-factor authentication enforced in Okta or Ping or whatever you're using for your SSO, and then someone creates a couple of IAM users in an account somewhere and goes in that way instead. So much the same thing, really.
Yeah, it's got to make sure it's universal. Yeah,
absolutely. So, principle of least privilege, as I say, good idea. Definitely something to work towards. Not something I expect most people to ever achieve. We'll be able to maintain over the long term. One tool in particular that's quite useful for that when you're working out where to start or particular things to investigate first. Cloud splaining, which is an open source thing from Salesforce, I think it was, is quite good at picking out some of the key risks associated with some of the IAM policies in a nice report that explains fairly well sort of what's going on and why things are seen as a problem. Auspex is something that one of my colleagues in South Africa built that's also open source, and it's more for sort of deep investigation into exactly who can do what to what resources by graphing out relationships between different users and their policies and the resources you've got deployed and things. So very powerful when you want to go that deep, but I imagine that's not a place most people will be starting. Just worth being aware that it's there. Reducing or eliminating long-lived credentials. Access keys tied to IAM users are a scourge and should be purged at all costs wherever possible. So I'm a big fan of, for instance, this new OAuth thing that GitHub Actions are doing now, so you don't have to put your IAM user access keys in your GitHub Actions secrets. You can have it authenticate to AWS for you each time it runs. Equally, use roles attached to instances rather than hard coding credentials in your app or in instances or things like that. And definitely when we're looking at things like SSH access, stuff like that, there are often ways to do this there too. It's usually harder. But for instance, if you're using something like HashiCorp or Vault, for instance, it can act as a certificate authority for SSH. So you can request temporary authentication certificates from it for your SSH connections. Bit hard, that one. Definitely not a place to start, but worth being aware that it is an option long term if you've got a lot of virtual machines running. Yeah, I think I mentioned instance roles already, but roles over users everywhere. And lastly, if you're lucky enough that you're in an environment that's got some nice privileged access management stuff deployed already, or something like Vault that can auto-rotate credentials, look at that. See if there's a way to make sensible use of that with the time and the budget you've got available. These are roughly in priority order for me. MFA is definitely the top one. Messing around with all the automated credential rotations, definitely bottom of the list. But these are all things that will make life significantly harder for an attacker when they start messing around in your environment. something that AWS has historically been very good at, but keeps introducing features to reduce the effectiveness of, is segregation between workloads and accounts. It used to be back in the day that you had an AWS account and it was a sealed box that you could draw a nice ring around, and that was that. Maybe allow some role assumption in or something like that, but there certainly wasn't much. And now with the more and more features they roll out into organizations and control tower and all these kinds of things, it becomes more and more common to see more sort of breaches in that hard perimeter around the outside of an account. But broadly speaking, separate AWS accounts for separate projects is a big one. Keep your dev environments away from production. Please keep your dev environments away from production. Security tools in their own account is another really good one. We quite often see people deploying Lambda functions to enforce security, like, I don't know, making sure your S3 buckets aren't public, or blocking off SSH access to the world, these kinds of things. They're often deployed as Lambda functions in the workload accounts. And the problem then is, if an attacker gets in a position where they can modify Lambda code in that account, they can then run whatever they want to run as those Lambda functions, and they usually come with really highly privileged IAM policies because they're doing security enforcement, right? So move those out into their own separate account and do role assumption from there into the workload accounts. And equally, all of your logs, take them out of the account where they're being generated, run an organization-wide cloud trail and have it all dumped into a very carefully managed logging account that does nothing but receive logs, and limit as few people to having access to that as you can. Network boundary controls are still as important as they always were. I think especially if you're running a lot of things in a VPC, EC2 instances, RDS, that sort of thing, security groups and all the rest of it, making sure that you're only allowing the traffic flows that you're expecting, definitely still important. And I would say also, it's quite common for me to see people doing VPC peering with third parties in some cases, but often between their own workloads. And the problem with VPC peering is it basically, you take the two and you smash them together and allow complete network flow across the boundary, unless you put the security groups in place. And so it's just one more option, one more way things can go wrong. So if you don't have to peer, look for alternatives that are sort of less make the environments less conjoined. And if you've got a third party who wants the VPC peer with you for things, MongoDB Atlas did this for a long time, for instance, ask them if they've got other options, because I'd definitely avoid joining a third party supplier straight into my VPC if I could. And the point I mentioned earlier about separating your CI/CD pipelines out is also pretty important, but there's a broader message there as well, in that having your shared tools and services live outside the environments that they're working with, and be segregated out where it's all possible, is pretty important in general. I would say one of the more interesting security shifts we saw over the last 10 years was people moving from Nagios and Zabbix and a lot of these old school monitoring tools to things like Prometheus, where instead of SSHing into boxes and retrieving data from them like that, what they'd actually do is you'd hit a web page and scrape some data that's being exposed, and that segregation, whereby now your monitoring system doesn't have direct reach into all of your stuff, actually is a really powerful security shift. And so segregating all these things out, splitting stuff out, not putting all of your eggs in one basket, is really quite important. And as an extension of that CI/CD bit, one of the things that a few projects, especially if you're working with Kubernetes, people have started to move towards is all the CI/CD we do at the moment is mostly what we call push-based. So the CI/CD system pushes changes into the environment from wherever CI/CD runs. What we're now seeing in some cases, Flux or Argo, for instance, if you're in the Kubernetes space, is where instead the pipelines run, or the CI/CD runs inside the thing being managed and reaches out to pull changes in. And what that means is that the credentials for modifying the environment sit in the environment rather than in a separate box somewhere else. And so it's an interesting shift. It's an approach that we've seen working quite well in a few places. more of a an architectural point to think about, I think, really, rather than a something that you can easily take away and run away with today. But it's definitely something to consider as you're building new things out and as a lot of these tools evolve in the future.
Nick, are you seeing any? I was about to ask if you're seeing any of these publish pull frameworks. Are you seeing any publish independent approval and then pull frameworks? So basically, the authorization for something to be published into production is actually a separate kind of container in and of itself, and the development publishes, and then the approval stamps it, either through signatures or otherwise similar process, and then publish. Then it gets pulled into production. Are you seeing anything that sophisticated?
Not that I've seen, no. I mean, most places are still relying on the approval workflows in their SCM tools, things like GitHub merge requests, stuff like that. And then the pull CI/CD piece relies on something being merged into main, and that's what it triggers based off. But that is definitely an interesting idea. And I think the challenge there for me would be, for most organizations, scaling a way of managing that effectively. The nice thing about those approval workflows living in GitHub is that everyone's in GitHub all day anyway. If you've got to jump into different environments and different places to start approving things, I can see that getting quite messy quite fast.
Yeah, I think that's one of the challenges. I think whenever you're designing this is people don't want to have to truly separate their credentials, right? Because when you're working on a laptop, it's like to actually separate it, you need a separate physical machine that you have to go and step into, or, in some places you have to go walk into a, card into a room, and there's lockdown workstations in there to do that kind of stuff that just you can't get to from remote.
Yeah, and obviously all of this depends entirely on your risk appetite. For a lot of organizations, that level of pain isn't worth it. Some of the crypto exchanges that I've done a bit of work with have that sort of procedure in place because they already had all of those facilities for managing transfers between their hot and cold wallets. Which if you're dealing with tens of millions of dollars of Bitcoin, starts becoming worth building, right? And if it's already there, you might as well take advantage. But I think for most organizations, that level of extra hardening probably doesn't bring enough of a security benefit to make it worth the pain of implementing and putting all your engineers through.
Yeah, it's painful on the development team.
Yeah, exactly. And one of the things the security industry as a whole is known for is rolling out security without really caring about the poor sods who've got to use it at the end of it. And that's definitely something that I do my best to avoid for exactly that reason. So Atlantis also does similar things. I don't know if any of you have come across this, but it's an open source tool that works with Terraform, and you can run that in your AWS account and have it monitor for approved merge requests in GitHub, at which point it can pull it down and then run the Terraform apply from wherever it is that you're running Atlantis in your account. So if you're working with Terraform and you like the sound of that sort of approach, Atlantis is worth a look. There's a bit of a general thing here about avoiding people in production. Easier said than done, but is a nice goal to aim for. Reducing the amount of time that your people have to spend in production, poking around and fixing things is a good goal from an operations perspective, let alone a security one. But the less time people are in production, the less potential damage they're going to do either accidentally or deliberately. So anything you can do in terms of increasing monitoring and visibility of production to developers without them having to actually jump into it, making it so that pushing changes to production through CI/CD is easy and rapid, so that people don't have to jump in and start doing things manually when stuff breaks. These are all good operational goals, but they have significant security benefits too. A lot of the more regulated organizations that I work with tend to also then start building systems around production access control and proper approval workflows. We have one client of ours, for instance, who it's all tied into their incident management system. And if there's an incident, as an engineer, you can say, I need to work on production in this account as a result of this incident. And approval goes to whoever the manager is, and the manager says, yes, please, let him in, and that's all logged and audited, and their access is then tracked. A special Bastion host is spun up, and all the command line logs are fed out of that to all their security monitoring people, and it's very nice and very efficient, and took them forever to build. But that broad principle of being able to tie someone being in production back to some sort of incident, and that being able to be logged is definitely worth looking at. If you're using SSM already, you can get logs out of SSM fairly easily, and that's quite a nice, quick and easy way to do it. But in general, that approach of having some sort of approval flow, keeping logs of what people do once they're in there, is definitely something to be thinking about. Authentication. We talked a little bit about some aspects of this already, but the key thing I wanted to flag here really is that there are a lot of different ways to authenticate to AWS. AWS themselves seem to have varying opinions on how you should do it. SSO seems to be the big one, but they still haven't published an API for it, so I'm still not the biggest fan. Generally, we see small shops doing a lot of individual IAM users and authenticating that way until they reach the point where they decide they need an SSO. Sometimes that's individual IAM users in individual accounts. Sometimes it's like an identity account that the users live in, and they then assume roles into other places from there. Both of those can work. I would say that I would move away from IAM users as rapidly as you possibly can towards a single sign-on. And that's mostly because access keys with users live forever. Access keys assigned through roles and single sign-on live for 12 hours max. So if anything goes wrong with those keys, the window that an attacker's got to do something with them is much, much shorter. So my personal favorite is a standalone SSO, be that AWS or Okta or anything else. But the other common one we see is Active Directory being used to federate into the cloud, which works pretty well in a lot of cases. I would just say that if you are doing that, make sure someone from your on-premises security team has had a good look at Active Directory, and that your Active Directory environment isn't as legacy and broken as quite a few of the ones I've run into over my years as a consultant. And then secrets management. This is the thing that a lot of organizations fall down on. The amount of times I've pulled passwords out of EC2 launch templates or user data, or things hard-coded in Lambda config files in the environment variables, or all of these kinds of things. And if an attacker can get read-only access of some sort into your AWS account, that might not initially sound as catastrophic as it could be, but if they can start reading some of the configurations and you've got a load of passwords lying around in there, they're likely to be able to quite rapidly move from that point into doing some more damage in some way or another. So having some sort of strategy in place for how you store secrets in a sensible way, I think is really quite critical. How those credentials are shared between systems is often a big point that people fall down on. And if you're doing CI/CD, having something in place in there to just check what's being committed to the repositories, just to pick out, oh, hang on, that looks like someone's checked a password in. Those look like AWS access keys. The truffle hog, I think the tool's called, is one of the really common ones we see people using. And you just run it as another step in your test suite. And that, for a lot of organizations, that catches quite a lot of mistakes before they get too much worse. In terms of how to do secret storage.
Hey, Nick. So we may want to defer the answer to this question. I'll ask it anyway, and then because we're running low on time. But one of the things as you're talking about around the periphery, like in your earlier slide, is where some of the problems come in. Something I'm always wary of is when secrets, before they get into a management system, they're shared via email, or I'll call you, I'll text you, I'll Slack you. There's 1,000 ways of doing it. You always feel uncomfortable with all of them. So is that one of those areas which is people actually do exploit, or is it like, yeah, don't worry about it, no one's going to steal your email? And
so like emailing back and forth, attackers will dig through emails if they can get access to them. Slack is often a gold mine, as is Confluence or file shares or any of that kind of thing. It's become a bit of a running joke with one of our teams that their extremely expensive fancy service basically boils down to hunting for passwords till they find some passwords and then using them to achieve the objectives. But like point-to-point communications over things like Signal, for instance, or other secure messengers like that, is generally reasonably robust, even just because an attacker then has to compromise a lot of people's phones and a lot of people's Signal messaging in order to get any amount of secrets. So as a starting point, things like that are quite good. Equally though, a lot of places have taken to just putting secrets straight into Secrets Manager at the point they're generated. And then if other devs need them, they can pull them out of Secrets Manager from there.
Okay, good, thanks. Bigger topic, but I think that's a great start. Thanks.
So yeah, as you say, conscious of time. So I'm just going to keep moving at quite a pace here, I think, and maybe skip a couple of bits. But secrets management in AWS, Secrets Manager is great, gets a bit expensive at scale. Systems Manager Parameter Store is fine so long as you're careful as to who can read things out of it. If you've got the manpower to run HashiCorp Vault or some other special fancy cloud secrets management solution, then great. But it's not usually worth it until you're at a fairly decent size already, I don't think, just because of the administrative overhead. Places not to put your secrets: EC2 user data, CloudFormation templates, application source code, random S3 buckets, especially if they're public to the internet. Environment variables in your Lambda configs. Anything that's plain text and that there's not a huge amount of access control on is generally a bad place to put them. And then I'm just going to pick out a few important things in terms of making this stuff work at scale, which was the title after all. When it comes to management, make sure you get in early with things like AWS organizations, a few basic service control policies, and having organization-wide features like guard duty and CloudTrail and things rolled out at the organization level, right? Especially if you're greenfielding an AWS estate, that would be like my day one, get that structure in place, because it's much, much easier to put it in early than to retrofit later. Also, though, a lot of people are having to retrofit later, and it is doable. It just needs some work, but it is worth the effort to spend some time doing that. Because it makes a lot of things much easier. Monitoring is much easier if you know you've got an organization-wide CloudTrail in place, for instance. If you're using a lot of different providers, provider-agnostic tooling might make sense. Say Terraform rather than CloudFormation for AWS and ARM templates for Azure. But we're an AWS meetup, so I'll skim over most of that. And also centralizing whatever security monitoring and things you are doing in one place, both through organization-wide guard duty deployments and things like that, but also putting the logs in one place. So if you do end up with an incident, you've only got one place to go look, will really help, especially as you start to grow bigger. There's a lot of different log sources in AWS. So for the sake of time, I'm just going to pick on two that I think are, or two types that I think are fairly important. If you only turn on one log source across the whole of AWS, make it CloudTrail and turn it on organization-wide. Because most attacks that happen at the control plane layer, like inside AWS itself, will be visible here. So if you've got to go investigating after an incident, these are the logs that the investigator's really going to want. There's then a lot of different log sources you can turn on for things like data events in S3 or Lambda function execution logs or KMS key access logs or all of these kinds of things. And there are cases where that makes sense. There are cases where it doesn't. It is very, very environment specific. And if you just turn all of them on, it's likely to massively run up your CloudWatch bill, and your finance people probably aren't going to like you for it. So look quite carefully at where you think it might make sense to have those logs for critical data stores or assets or what have you. But definitely don't just turn them on everywhere. The other aspect of security that unfortunately the security industry people don't like to hear is that there aren't enough security people, and security shouldn't really live in a dedicated security team anyway. So one of the things I've been pushing for ages is telling security teams in organizations to go sit with the engineers, buy them a beer, get to know them a bit, and start working a lot more closely with them. Because at the end of the day, security works far better if the engineers understand how to do most of it themselves and go to the dedicated security people for specific help and advice where they need it. the other extension of that is that most of the good cloud security people I know are ex-engineers who moved into the cloud space rather than following the route I did. They were engineers, they became cloud engineers, they became cloud security people from that. And one of the reasons for that is because of the level of automation that they tend to chase down, custom automation or other stuff they've pulled off GitHub or what have you. But that focus on automation that comes with an engineering background really does help. And if your in-house security team, if you've got one, isn't driving that route already, have a chat to them about it and see what you can get them to do. Unfortunately for businesses, cloud security is bloody expensive. Hiring in cloud experts in general is not cheap, as most people will probably know, which is great for all of us, long-term career development and so on. But it's an expensive thing to do. So for most organizations, this gets quite pricey. And the best way to scale it is by helping all the engineers out, which is one of the reasons I'm here talking to everyone here. And in fact, I'm going to skip over for that one and that one in the interest of time. So just to conclude things, while I've still got a couple of minutes left, your cloud security depends on a lot of stuff. And it's not just what's running in AWS. It's also your single sign-on systems, your source code management, your CI/CD, what your devs are running on their laptops even. And so definitely don't forget about all of that when you're trying to defend your cloud estate. Things to focus on once you've got the absolute basics, like your S3 buckets not being public and things like that. Your IAM policies to make sure they're not just admin everywhere. Your secrets management, because a lot of people get that wrong, and it takes a bit of effort, that one. Segregating things out properly, so different workloads live in different accounts and dev and production are nicely separated. And looking at your CI/CD, what you're doing there and how that works. I'd say those are some critical areas. And I'd definitely look at automation for as much of this as you possibly can. It's beating the same drums that a lot of people have been for a while, but AWS wrote a white paper called Automating Governance on AWS, which sounds really dry, but actually has a lot of really good tips about some basic automated security controls you can throw in on top of things like config. Some of the rule sets that come with config work quite well. Just as a way of getting started with some of this sort of security automation and enforcing some of the best practices and things in your AWS estate. And I did promise I would mention my main side project at the beginning of the talk. So this is Leonidas, going back to Lambda functions here, because I'm a big fan of Lambda too. Serverless is fantastic. Essentially, it's a generator for building a web API for running attacker actions. So instead of needing to understand at a deeper level what an attacker is likely to try and do, you can grab the use cases that we've already published, deploy the thing. It's a bunch of Terraform and a AWS native CI/CD pipeline is how it works. And it gives you just a straight up web interface that you can run a bunch of different attacks through and see if you're getting the right logs in the right places to be able to do something about it. And so I built this to work with a lot of our clients who are building their own security monitoring systems for AWS. They've got a security operations center or something. We wanted to work with them to get better at spotting attacks. And this has helped us automate a lot of that, but also make it easier for their people to then go repeat various bits and pieces as they're building out a lot of their defensive tooling and detection rules. Lowers the bar to entry and speeds everything up. And with that, I think I was 2 minutes over. Sorry about that. But hopefully that was useful. And I guess we probably still got some time for some questions.
We do. I'd like to get the raffle in,
of course.
And I'll put in a plug in the chat. We have the post-meeting survey, which would love you to fill in, just because that's how we get better. So I have one trivia question. Nick, do you have one that you want to ask?
Yeah, I can do one.
Okay, before you do it, so the rules here are, if you know the answer, type it in the chat, and the first person who gets it right, and it's your question, so you got to look at the chat and tell us who got it right. but first person wins the $25 AWS card. So, Ed?
Okay, so in the spirit of staying vaguely on the sci-fi theme, but being British, obviously I can't go with an American sci-fi TV show. So today we're going to go with which British city was Captain Jack Harkness and his Torchwood crew based in for the TV show Torchwood.
And I'm not going to answer that because I do know the answer to that one.
If you're a Doctor Who fan, it might have turned up in a few episodes of Doctor Who too. And Torchwood was the Doctor Who spin-off there.
There are only so many cities over there.
For such a small island, it's got a surprising number, to be fair. But there's my Zoom chat window. Here we go.
We've only had one guest so far. Oh, come on,
Oh,
folks.
dear.
Yes.
Yay,
yes.
Cardiff. There we go. Well done, Eric.
Okay. So, so Eric, send an email to the email list that, Eric, did you post that or are we still just sending it to you and me?
Nope, I did. It's Boston okay. Boston AWS user group at googlegroups.com. That's not a mouthful there ever was.
Okay, if you can post that in the chat. Okay.
So have we started using the Google Groups or we still use Slack?
You still use Slack.
That's just for email, Drew.
That's just for email workflows. That goes to all of us.
Okay, and so we have a second card, and I have one that's actually kind of on target, and it's got a follow-up question if the main question is too easy. And the question is, which sci-fi show was premised on a massive security breach, and what kind of breach was it? And you know the shows I watch, so come on.
Hey, Nick, in the meantime, can you post the Leonidas link into the chat as well? I think that's a pretty cool thing.
Yeah. Just grab that. Yeah, so in fact, that's one of the ways that I learned an awful lot about serverless things in AWS was trying to build that out. And I will also dig out a link to that white paper.
Brian, you want to repeat the question? Just
I'll enhance it a little bit. Which sci-fi program, recent sci-fi that I've mentioned about 1 million times, was premised on a massive security breach that killed hundreds of billions of people?
unfair for our newcomers.
I'm going to throw out some hints. Starbuck, Apollo, Adama.
Clearly, I don't watch enough sci-fi TV here.
Okay, well, that one's going to go begging. It was Battlestar Galactica. It was, sounds like, yeah, Eric, good, nice try. From a security point of view, the show was premised on essentially a honey trap done by an android to the head of security. So.
But there's also a scene in, what was it? What was the one with the title was like a number of minutes?
33?
33 minutes, whatever, where maybe it's a different one, where they show this great visualization of the Cylons attacking the firewalls and like hitting one firewall and getting through the next.
Yeah.
That was like an iconic scene, which I can't forget that one.
I have to say, rather disappointing, as is the case for most things involving film, where it's it's whatever it is that you know well. There's generally a sort of an inverse relationship between how accurate the hacking scene is and how exciting it is. And if you go back to the the 1995 film Hackers, which is where about half of all InfoSec jargon and jokes come from. The hacking scenes in there are absolutely god awful. I think the only movie that really springs to mind that did them well was The Matrix Reloaded, where the whole like Trinity power plant scene was all using real tools, real world things that probably would have worked when she was doing it. So it was quite carefully done, that one. You know, overshadowed a bit by the explosions and gunfire, but yeah, that was pretty good. Unfortunately, it looks like AWS actually archived the framework that I was thinking of, all the white papers and things. So instead, the security pillar of the well-architected framework is as good a place to start as any. Yeah, if you're not familiar with the well-architected framework, it's what AWS are pushing everyone towards. Yeah, and most of what's in there is pretty decent as a starting point, so worth a look.
Okay, Brian, you got a backup question?
No,
Want to go for a random number generator?
oh, come on, somebody. So we're participatory. Someone here has a trivia question that they can ask and let someone else win a thing.
I mean, I can do more British sci-fi if
Yes, sure. Try one.
Why not?
Okay. So which British TV series which British comedy TV series, sci-fi, had a character named Crichton? This goes a bit old school. So if people are, if we've got a younger crowd here tonight, that might be things people are less familiar with. But yes, Red Dwarf. There we go.
The funny thing is, Nick, Michael Meyer typed the answer about 5 minutes ago.
Oh
Yeah.
Oh, because
he knew you. Okay. All right. Still a winner. Still a winner.
There we go.
So send an email to that list, and we'll get you the $25 gift card. And we may expand deep into dare I say Blake 7, if you can remember that, Nick.
Oh wow.
Yeah, I was a student in England when Blake 7 was happening. So I want to say thank you to our speaker. Thank you to our audience. In 2 weeks, we are very likely going to have a talk on IoT, which we really haven't had one of those in a while. Please let us know in the survey, because hopefully you fill out the survey. Tell us topics you'd like us to cover. Tell us topics that, oh my God, not another talk on, you know, let us know, because there's a pool of speakers and we can reach out and get speakers for kind of anything you want ish. So any last questions about security tonight?
Also, Nick, while people think of questions, can you let us know how people could contact you?
That is a very good point. Probably easiest is going to be Twitter, so I will just dig out my Twitter profile.
The one thing I would back up with Brian is for folks that are thinking, oh, I'd like to learn about this, but there can't be anybody else that's interested. Don't worry about thinking about how many other people are interested in it. If there is a topic that you would like to know more about, or that you are particularly interested in or exploring, throw it out there. Let's go find those ones, because you'd be surprised how many people are actually interested. With 8,000 people that are looking at this, you know, at these published presentations, you'd be surprised how many people are interested in a given topic.
Just a follow-up thing. You know, he's making a nice open source framework. Maybe Brian can help out and make a Alexa, so he can just say, Alexa,
attack all the things.
Yeah, that won't go
just
south.
go and hack the site, you know, just joking. But it might be a good idea, right? A couple of the keywords, it generates a Lambda.
Yeah, I mean, the whole thing's it's a huge stack of Python code generation, basically ingesting YAML templates and spitting Lambda functions out the other side. So I'm sure we could tack on some Alexa in there somewhere.
But if we did, we'd have to deny it.
So related to that, it's been years since I've programmed Alexa. Is there a way to push notifications from like a regular user, and not Amazon? Can we push notifications?
Yes, yes, you can now.
So if someone set that up to get operational alerts, is there existing Alexa skills to do that?
I don't know that there are existing skills to do that, because that involves, credentials back to your company. But you could, I will say, some years back when I worked at Imprivata, which was a highly security conscious system, because we were doing text messaging to prescribe narcotic drugs, so we, had to be right. We had the notion of a flash briefing that would say, you'd come in and say, Alexa, what's up? And it would give you the status of the overnight job runs.
Yeah. Anyway, didn't make to get way off topic, but it'd be nice to have a way to just push notifications sometimes, to have it show up on your Alexa devices.
Absolutely, absolutely, yeah.
All right. Anything
Okay.
else from anyone today?
All right.
Nick, that was fantastic. That
Yeah,
was a great talk. I really found that informative, interesting, well presented. I know more than I did when I started, so that's great.
Fantastic. I'm glad you enjoyed it.
Excellent. Yeah, excellent. And a shout out again, please fill out the survey, because we can only get better if you tell us where we're doing things well and where we're doing things not so well. Okay. All right.
See you, everyone.
Cheers.
Bye, everyone.